Hi there, my name is Madison Taylor, and today I'm going to be talking about bee botany and specifically the concept of flower constancy in Apis mellifera. So, quick overview. First, I'm going to define flower constancy. Then, I'm going to go over the different ways that both the bees and the pollinating flowers benefit from this. Then, I'll review some prominent theories to explain the concept of flower constancy. And I'll kind of end with a new fun emergent theory that involves fungi. So what exactly is flower constancy? Flower constancy is the tendency for an individual forager honeybee to visit a single species of flower during their foraging trip. It's a coevolutionary phenomenon, so you can't understand it in its entirety by just looking at the honeybee or just looking at the flower, but you have to look at how they've worked in tandem over the years to create this fascinating concept. It's the result of millions of years of this intimate, mutually beneficial relationship between honeybees and the flowers that they pollinate. So how exactly do the flowers benefit from this? Well, flowers can't exactly move, so they need a little bit of help with reproducing, and that's where the honeybees come in. They gather the pollen on their hairs and they disperse it throughout the field, and in essence, this is how a plant is able to survive over the years, is that their DNA is dispersed by the honeybee. And so how do the bees benefit? Well, first, I think this is a really neat picture, a neat close-up of a bee feeding on nectar, and you can also see some pollen particles there on the end too. But so the main benefit for the bees is energy. They collect nectar, pollen, honeydew, plant spores, animal dust, really anything that they can conjure off of that flower that they can then utilize and turn into energy. But there are other reasons that the flowers benefit the bees. One is protection from the elements, and kind of something that works in tandem with that is they're able to rest on flowers during their foraging trip. And as we learned in one of our lectures, some foraging honeybees are thrill seekers and they just enjoy seeing the different types of flowers. Um, so the flowers can provide some fun for the bees. Since being coined by Aristotle, there have been several theories to attempt to explain the phenomenon of flower constancy in honeybees. Some are contradictory, and some actually work together to illuminate more information, but the first is known as the interference hypothesis. It's rather Darwinian, considering it emphasizes evolutionary stunting and behavioral limitations, specifically in the honeybee's memory. So what this theory says is that honeybees are constant to specific flower species because learning to pollinate a new flower would interfere with their memory of pollinating the previous flower. Um, However, this theory doesn't have much support from the scientific community anymore. It was just one of the earlier theories that attempted to explain flower constancy, but it was still integral in setting the foundation for some of the newer theories to emerge. The second theory is known as the learning investment hypothesis, which emphasizes efficiency versus energy displacement. And what this theory is basically saying is that the time it would take a honeybee to learn to pollinate a new flower is taking away from the nectar that they could have been receiving if they had just stayed constant to the flower they're already familiar with pollinating. While this is technically true, it has been found in studies that the time difference in this new learning behavior is rather negligible as far as the energy rewards go. We're going to call the third theory behavioral flexibility and adaptability. And so while flower constancy was previously linked to color and spontaneity, new research is showing that honeybees are a lot smarter than that, and they can actually adjust their floral constancy given the ecologically realistic rewards available to them in the environment. So what honeybees are looking for is flowers with the highest energy concentration, and they're able to adapt based on the volume, concentration, or number of a combination of the factors of nectar, pollen, color, petals, which is a really important consideration in the midst of our constantly changing ecosystem during climate change, because it illuminates a way that we as humans and we as cultivators of plants might be able to better assist honeybees in their foraging trips. New discussions being had that I find particularly interesting are how mycorrhizal fungi can affect the relationship between plants and pollinators. Mycorrhizal fungi are the result of a mutually beneficial relationship similar to plants and pollinators, but this time it's between some fungi species and plant roots. And the picture on the left is a plant roots with no mycorrhizae, and on the right is with probably miles of mycorrhizal fungi. And what these do is it connects plants to plant roots to other plant species. It helps break down nutrients, gain nutrients. It purifies the soil. And so the relationship is really beautiful, and it's also been found to affect the plant traits as far as nutrients or leaf production. And this in turn can alter their relationship with pollinators, though more research needs to be done in the area. So I put out three things that we should take away from this presentation, and the first is that the exact cause of floral constancy is not precisely known, but multiple theories do exist as to why the phenomenon occurs, and it's important to kind of look at all of them separately and then together to look at the old theories and the emerging theories and to kind of put them all together to try to make more sense of it. It's also important that we consider the context of the environment and that it's possible that bees are considering the most ecologically realistic rewards and are trying to achieve the highest volume and concentration of nectar from a flower in a given environment. And finally, we might also benefit from looking at what other aspects of the ecosystem might affect this plant pollinator mutualism. And that could be again considering the environment, or like I talked about, it could also be mycorrhizal fungi and imagining how microbes below the soil are affecting plants and therefore their relationship with their pollinators. So thank you for listening.